The spectrophotometer technique is to measure light intensity as a function of wavelength. It does this by 1. Diffracting the light beam into a spectrum of wavelengths. 2. Direct it to an object. 3. Receiving the light reflected or returned from the object. 4. Detecting the intensities with a charge-coupled device. And 5. Displaying the results as a graph on the detector and then the display device. Instruments. Light source. Provide a sufficient of light which is suitable for marking a measurement. The light source typically yields a high output of polychromatic light over a wide range of the spectrum. Monochromator. Accepts polychromatic from a lamp and outputs monochromatic light. Monochromator consists of these parts. First, entrance slit. Second, collimating lens or mirror. Third, dispersion element. Fourth, focusing lens or mirror. Fifth, exit slit. Exit slit. Dispersion devices. A special plate with hundreds of parallel grooved lines. The grooved lines act to separate the white light into the visible light spectrum. Focusing devices. Combinations of lenses, slits, and mirrors. Cuvettes. Designed to hold samples for spectroscopic experiments. Detectors. Convert photons into an electrical signal. Next, display devices. The data from a detector are displayed by a readout device, such as an analog meter or LCD. Application. 1. Concentration measurement. 2. Prepare samples. 3. Make series of standard solutions of known concentrations. 4. Set spectrophotometer to the maximum light absorption. 5. Measure the absorption of the unknown and from the standard plot, read the related concentration. 6. Detection of impurities. 7. UV absorption spectroscopy is one of the best methods for determination of impurities in organic molecules. 8. Structure elucidation of organic compounds. 9. From the location of peaks and combination of peaks, UV spectroscopy elucidates structure of organic molecules. 10. The presence or absence of unsaturation. 11. The presence of heteroatoms. 12. Chemical kinetics. 13. Kinetics of reaction can also be studied using UV spectroscopy. The UV radiation is passed through the reaction cell and the absorbance changes can be observed. 14. Detection of functional groups. 15. Absence of a band at particular wavelength regarded as an evidence for absence of particular group. 16. Molecular weight determination. 17. Molecular weights of compounds can be measured spectrophotometrically by preparing the suitable derivatives of these compounds. Advantage. The advantage of the double beam design is high stability because reference and sample are measured virtually at the same moment in time. Disadvantages. The disadvantages are higher cost, lower sensitivity because throughput of light is poorer because of the more complex optics, and lower reliability because of the greater complexity. Electrophoresis principle. Any charged ion or molecule migrates when placed in an electric field. The rate of migration depends upon its net charge, size, shape, and the applied electric current. Instrumentation or reagents. Power supply. Electrophoresis is done under conditions of constant voltage, current, or power. Migration rate is kept constant by using a constant. Current power supply. Buffers. Function include: carries the applied current, establishes the pH of the system, determines the electrical charge on the ionic strength, influences conductance of the support, thickness of the ionic cloud, surrounding a charged molecule, rate of its migration, sharpness of the electrophoretic zone. Features of an ideal buffer: does not interfere with the ability to detect the analyte's interest, maintains solubility of the analytes, maintains buffering capacity through the analyze and produce the desired separation. Commonly used buffers include low pH or acidic. Support media. Pure buffer solved in a capillary starch gel. Separate macromolecules on basis of surface charge and molecular size. Cellulose acetate. Require clearing before densitometry, hardly used in routine clinical application. Equipment use: power supply, electrophoresis chamber containers for staining and the staining gel applicator. Applications: DNA analysis, protein analysis, antibiotic analysis, vaccine analysis. Its advantages are high separation efficiency, short analysis time, low sample and electrolyte consumption, low waste generation, and ease of operation. While the disadvantages: due to small diameter of the capillary tube, heat is dissipated that causes increased diffusion. Due to this, resolution is not always proper.